So again, we finished with your very, very, very good friend, Benoît Mandelbrot. And we said that with Benoît Mandelbrot, the difference, the main difference, there are many differences with what can I say? Yeah, with Greek and Platonic and Pythagorean geometry, because he introduced this kind of biological sensitivity, you said, and he invented it. And you said we weren't online when you said that you were amazed, but it was what he was capable, your friend, your very good friend Mandelbrot, was capable of doing, like inventing when a new geometry where people will not talk about geometry anymore until he did that.
I thought that was wonderful.
Yeah.
And maybe it inspired some young people to become mathematicians or become geometers.
Yeah.
At any rate, it was also art, because some of the books on fractals were art books, coffee table art books.
Yes.
So I think it was amazing.
And you remember, we were finishing by saying that in a way, he reintroduced some kind of like motion into geometry, because when you looked at it, it's like if it is a process itself, like a growing, like if something is actually growing, and there is some. You remember I said I was very proud of that, but so for very small things, you can be proud that we could call that genetic geometry or something.
Not bad. It's an organic geometry. It's similar. The geometry of creation, is that what genetic means?
Yeah, genetic, exactly, is what I meant. Mm-hmm. What I meant. So there's something that is creating itself all by itself in the time, because I thought it was interesting to say. And so he reintroduced time in a way.
He brought back geometry. Well, he wasn't the only one. There was a Canadian mathematician whose name escapes me. Coexter, I think. But I think Benoît created a whole public for geometry, for mathematics. And he had an unconventional style. He worked more with intuition and the human brain has so much space devoted to the visual cortex. It's a shame that mathematicians declare that everything should be algebra. Of course, I say this, algebra has won. Algebra is very fashionable.
It wasn't at all in the beginning.
But I personally don't have any algebraic intuition. My work doesn't involve algebra at all. And I'm personally very happy to see geometry come back and beautiful images come back. Artistic images. So
even if it is not your kind of imagination, as you say.
Right, but it is beautiful stuff. And remember when I met Benoît, he was unknown. So was I. We were both outcasts.
We were both at the end of the
on
building.
the last aisle. This is the two outcasts, the two oddballs were there.
Exactly.
So this is.
And now you're the superstars, both of you.
Yeah, well, Benoît isn't with us anymore, unfortunately.
I know, but still, now he's also a superstar, but in the sky. That's
right. But there we were, and we got to talking because we were all the way at the end of the building where nobody was, and.
So now talking about time, because we are supposed to talk about time, like the reintroduction of time, and talk about time and
is it infinitely divisible, or are there atoms of time?
Yeah,
exactly. Same with space. Is it infinitely divisible, or are there atoms of space?
That's a good question, because in a way we could say time is in itself the expression of infinity. We could say in a way it's what Bergson will say. It's what Bergson will say, but what could say a mathematician about that? Because the reasoning of Bergson is that because time is the proof that there is not only determination. A determination is the image of space. It's when we think that the world is just space, we think everything is already here, because space is like, oh, everything is already here, so everything is determined by what is already here. But time is just the proof that actually everything is not already here.
Yes, time is creativity.
Exactly. It's a proof that things are not already here. So it needs some time to things to appear, things that are not there. And so in a way, if we take the word infinity literally, time is actually the proof that things are not finite. They need all the time to be finalized out beyond themselves. And to be finalized beyond themselves, to go beyond themselves, to transcend themselves, you know how much I love this word, transcendence, to transcend themselves, they need time. And so time is actually in itself infinity, the proof of infinity. So what do you think about this kind of Bergsonian argument?
Yeah, Bergson, Élan Vital, by the way, in English, I think George Bernard Shaw, the playwright, used to call it the life force.
Oh, he
in
did
his
that.
play Man and Superman, Don Juan and Hell chapter, or Back to Methuselah. Which
but I think Élan Vital is more than force. The translation is good, but it's not completely. L'élan is just, it's also when you feel attracted. You know, it's just...
The vital impulse, would that be a better...
Yeah, impulse is good to... It's good because it's the idea that you pushed, but it is not determined where you are going to go. And élan means just that. It really means that in French. Force is not too bad, but we also have force.
It loses the poetry if you translate it that way.
It loses something that is just...
Something important.
The undetermined part is more...
Now, there's a humorous aspect to this, which was physics for a long time has been denying that time exists. And
exactly.
You have to study a lot to deny the obvious evidence that we all have that there is something called time. But physicists have this professional deformation. And part of the reason is that, first of all, that special relativity tries to make time into space. So you get four-dimensional space-time. It doesn't quite work, but it almost works. Mathematically, time is a dimension that's a little bit different from the others. And then there's the fact that the laws of physics are time symmetrical. You know, if you look at microphysics, you can go forward, you go backward. You can't really distinguish, not over a short period. You know,
it doesn't take into account the growth. So it's like if time was basically in itself biological, so it grew, but it doesn't take into account the growth of it.
Yeah. Oh, talking about time, by the way, I don't know Sanskrit, but in the Bhagavad Gita, there's this famous moment where Arjuna asks Krishna to stop revealing his divine form, and Oppenheimer in the movie quotes, "I am become time, the destroyer of worlds." That's from that moment, I think. Sentence. Yeah, but time in Sanskrit, I think, is the same word for death. So maybe the original could be, "I am become time, the destroyer of worlds."
Yeah,
not
because
death, the destroyer of worlds.
And it's there that you can see. It's actually the vision that has Plato about time. That's the reason why he wanted to eliminate time. He said time is always a negative force. It's a negative process. That's the reason why I tell you, because for him, mathematics is all about space, and space is actually what escaped time, for him. And so that's the reason why mathematics it's what is the closest to the world of ideas that are eternal. It's the main idea and so you can see that Plato is Indo-European. So it's an idea that also comes from India that I'm sure in a way Plato absorbed in a certain way. So that's true that it's the death for Plato as in Sanskrit, as you said. Yes, it's true. It's true that there is something about time that is, and
remember special relativity, what a big shock it was. People forget, in the early 1900s, people were profoundly shocked by this idea that time could run differently to observers in motion relative to each other. And it does, because the basic problem is that the speed of light, whoever measures it, will always be exactly the same in a vacuum.
Exactly.
Even if I'm moving very fast in this direction and you're moving very fast in that direction and the beam of light is coming along, you'd think that if you're going in the direction, against the direction of the light beam, the light will seem to go slower. No, it doesn't.
It doesn't not because you can't even add anything to the speed line. It's what is really striking.
It's very strange.
Yeah, it's 320,000 kilometers a second.
In a vacuum, it's a constant. Even if you
exactly.
If you try to catch up with the beam of light, it still
doesn't add anything.
It still goes at the same speed.
Exactly.
You can't catch up with it.
So that's the reason why, in a way, you can ask yourself: is it really a speed? Can we still call it a speed? Isn't it something else than speed? It's where it comes.
Another problem is that time in general relativity goes slower if you're in a gravitational field. And they've measured that. You take there's an oscillation of some atom, which is a very good clock. And if you measure it on the surface of the Earth and you measure it in the satellite, it goes faster because the gravitational field
it's incredible because now we can verify it. But Einstein
GPS
just
is based on this.
But Einstein just deduced it theoretically.
He deduced it theoretically. And you take it into account now with GPS because the timing is so accurate that they have to know that a clock will run at a different speed in the satellite than it'll run on the surface.
If they didn't have that, the difference will be like kilometers and you couldn't do anything.
There would be an increasing difference in the timing. Yeah. So this that initially was a theoretical prediction, then the Moss power effect, I think, showed it on a tower here on Earth. It was a physical effect that enables you to measure time incredibly accurately that won a Nobel Prize for a young physicist. And now I think it's just used routinely in GPS and systems like that, which depend on very accurate clocking. That's a surprising fact. And if, for example, I don't know if black holes exist, but the astrophysical evidence seems to be that they do. And as you fall into...
We don't know if black hole exists because most physicists now, they are sure that black hole exists. Almost all of them.
Well, yes,
not all of them.
But it's a singularity, you know,
Sure.
and singularities are bad. It's a place where the laws of physics fail. You go to infinities. So falling into a black hole, you never get there. To an outside observer, it takes forever to reach the event horizon.
Of course.
But to the person falling in, it's a finite amount of time.
Exactly.
So this is an extreme illustration of...
So you can't even say what it is. That's the point. That's the problem.
And then Gödel found a solution of Einstein's equations with a rotating universe where you cannot have an arrow of time because you can have a loop where you go back into your past. That was a present that Gödel did for Einstein. In a Festschrift for Einstein, Gödel, I think, included a small paper on this, talking about the unreality of time, at least from the point of view of general relativity, because sometimes you can't establish an arrow of time.